Okay, so this is what the Excel sheet should look like. Um, the one that we're going to be working on today. Oh, hey, I see Nathan now. um, so I will be doing things, of course, the way that I like to do them. And then everything I am going through will allow you to get full credit on all of the Excel sheets, or on all the Excel graphs, I guess I should say. You will be turning in 5 or 6 graphs for this. So this is a very graph heavy um, lab, and that's going to be the majority of your grade. So please make sure that you're either following along as we're going, or if you have any questions, go back and watch the recording, which I'll probably put up tomorrow. Um, so that you can make sure that you get all the credit for those graphs, because again, that's going to be the majority of the grade for this lab is just those graphs. And like I said, we will do this. There is a quiz for this, so we'll do it next lab period. Now, next week, we do not have lab. So you can come by at any point that you want to take the quiz, if you would like to take it before we meet in 2 weeks from now. Okay, so in the lab itself, kind of the background of it, it is essentially the same exact thing you guys did in your own lab last week with Beer's Law. Crystal violet was reacted with sodium hydroxide, and a time versus absorption graph was recorded. And they did this with 5 different experiments. Experiments 1 and 2 were done at the same temperature, but different concentrations of sodium hydroxide. Experiments 1, 3, 4, and 5 were done with the same concentration of sodium hydroxide, but different temperatures. So I'm just gonna real quick open up CSE Pub to show you what the actual experimental conditions were. And this is actual data that someone took.
Right away.
Let's see. The CSE Pub. Right in here, you can see a table with all the experimental wait, I went the wrong direction. A table with all the experimental conditions. So for experiments 1 through 5, we can see 1 and 2 apparently, or approximately the same temperature, but we have different concentrations of sodium hydroxide. And then experiments 1, 3, 4, and 5, we see we're increasing temperature. So experiment 1 is the first one we're going to look at. And essentially what happened is we kept crystal violet at a very, very low concentration. So it's 2.1 times 10 to the negative 5 molar. You guys were close to that concentration. I think you guys were at 2.5 times 10 to the negative 5 molar. And then the sodium hydroxide concentration was 0.1 molar. So what they did with this is they kept the sodium hydroxide concentration significantly higher so that it essentially doesn't change during the reaction. So we can look at how just crystal violet concentration changes over time and how it affects the rate of the reaction. With that information, we are doing a reaction to figure out just what the order is with respects to crystal violet. So we can take experiment 1 data and we can take it and do concentration versus time, natural log of concentration versus time, and 1 over concentration versus time, and see which of those graphs result in a linear correlation between concentration and time. With the linear graph, we know from kinetics, we know that is the order that it corresponds to. So if we have concentration versus time being linear, then we know that it is 0 order with respect to crystal violet. If natural log of concentration versus time is linear, then we know it's going to be first order with respect to crystal violet. And if 1 over concentration versus time is linear, we know that it is going to be second order with respect to crystal violet. So that's what we're going to do with experiment 1. We're going to take the data and we're going to look at how that concentration changes over time. After that, we are going to essentially determine what the order is with respect to crystal violet. After that, we will then go through and graph all of our experiments and figure out their K values, their rate constants. We will find that this is, again, we're looking at a pseudo reaction where we're keeping sodium hydroxide so high that it's not essentially changing, but the slope of our line still won't be exactly K. It will be what's called K effective. So I'm sorry, the thing is down here. So essentially what we did. It's around here somewhere.
So all these ratios, and then you can use other things too.
Here we go.
These are all conversions.
We've essentially set our, we're gonna be able to, since this is not changing, the hydroxide concentration in our K will be equal to our K effective. So we'll be able to use our K effective to solve for our actual K of our reaction. So we will be looking at our K effective, which each of these graphs down our actual K value. Sorry, going back down. After we find all of our K effective values from our different graphs, which we're going to do in part 2, we can then figure out our order with respect to sodium hydroxide. We'll be using this equation right here, where we take the K effective from one experiment divided by the K effective in another, and set it equal to our Ks over our sodium hydroxides to their n value. So this is very similar to what you do with the kinetics graphs. I'll show this a little bit more in detail when we get to this. I'm gonna let you guys do your own math, but I'm gonna show you how we're gonna approach this problem. After that, our last part of this lab is gonna be calculating our activation energy. So we're gonna do that by using our different temperatures. So experiment 1, 3, 4, and 5, where we have the same sodium hydroxide concentration, but we have different temperatures. We're gonna figure out their K values. Well, we're gonna figure out the temperatures, and then we're going to find their K values, and from there we're going to graph that to figure out our or to make an Arrhenius plot. And that Arrhenius plot, where we're going to take ln K effective versus 1 over temperature in Kelvin. The slope of that line will be negative EA over R, or activation energy over our gas constant in energy. Okay, any questions about the general setup of what they did in the lab and what we're going to be doing? Okay, so let's go ahead and get started. I'm going to take my first two, just my experiment 1. I'm going to copy this, and I'm actually going to start a new sheet, and I'm going to call this experiment 1. And I'm going to paste this on. So I'm going to paste this on. And the only reason that I'm doing this is because I like to have a new tab for each of these, so I don't have a bunch of graphs on one tab. Again, we're going to do like 5 or 6 graphs, so it can get really confusing with that many graphs. You don't have to do this, but I find it easiest. As I said, with experiment 1, we're going to look at concentration versus time, the natural log of concentration versus time, and 1 over concentration versus time. However, it's not going to be actually concentration, it's going to be absorption, which we did learn from our Beer's Law lab is going to change proportionally to concentration. So it doesn't really matter which one we use. So what I'm going to do is I'm going to copy the time here, and I'm going to put it into another column. And then I'm going to do the natural log of absorption.
So,
and then I'm going to do this one more time.
Are you not understanding where it's coming from?
And then I'm going to do 1 over absorption. So I'm going to get Excel to do this math for me. So in my first column, where I'm going to start putting in the natural log of absorption, I'm going to type in equals, and then I'm going to type in ln, and that's going to say return the natural logarithm of a number, open parentheses, and then I'm going to click on the cell that contains that absorption value. Then I'm going to do a close parentheses, and then I'll press enter. Okay. Once I press enter, which you get a number like that, and I'll zoom in a little bit so you guys can see a little better.
That comes directly from the balance.
So again,
So like here,
the equation I did is equals ln, open parentheses, and I clicked on the cell. You can also type the cell letter and number, and then close parentheses.
There was.
And then you can press enter. So that has taken the natural log of that absorption value. I am then, if you see right here, you can see there's a little box at the corner of this box. I'm going to double click on it and cause that calculation to go all the way down. So it's going to take the natural log of all of my absorption values from my B column. Okay.
When you create your conversion factor, you put what you want at the top and you put what you have.
If anybody has any
That way what you have goes away.
Mai, are you connected now? Sorry, I just realized that you sent me a message.
Oh, yeah. I was just, I disconnected. So now I think I have 2 names on the Zoom.
Yeah,
But
that's fine.
yeah, I'm
It's
following.
likely, yeah, okay, good. If anybody is not following, please let me know. Okay. Now we're gonna do this. We're gonna do another calculation, but with 1 over absorption. So we're gonna do equals 1 / and we're gonna click that same cell, the cell that has our absorption values, and then enter. So this one is 1, it's equals 1 / and then in my case B4, because that's the cell that I used. They're the cell that I have absorption in. And again, to make that equation apply to all of this row or this column, I'm going to double click on the box.
17 of these, 12 of these, and 10 of these. And now we'll give it a try. Yeah, okay, perfect. Either one is correct. So it's just a kind of weird exception we do.
Okay, did everybody follow? Everybody good to start making graphs? Okay, so we're gonna make our first graph. I'm gonna zoom out just a little bit. Try not to take these up here. If you take those, they can do some weird stuff. So I would just suggest taking just the numbers. So you're gonna pull or click and drag, and then take all of these, or take these 2 columns of data. Then you're going to go to insert, and we're going to want a scatter plot that does not connect the dots. So we do not want the one that connects the dots. We want the ones that does not connect the dots. The one that does not connect the dots. So it should look something like that.
Word problems. So, and it goes back to this one. So like,
Okay.
I know.
Now, at this point, I'm going to show you what you need to do in order to make your graph a perfect graph. So first, we want a chart title that is descriptive. This is experiment 1, where we just have absorption versus absorption versus time. So we can do crystal violet, absorption versus time, reacting with NaOH, and that can be EXP1. I guess that should be it. So something like that. So something that we know what's going on in this graph. And I'm probably going to do a very similar title for my other 2, but I'm going to do natural log absorption and 1 over absorption. Then you're going to want to add axes titles. So if you are on a PC, there's a plus, and you can just go to axes titles. If you are on a Mac, you're going to have to go up to chart design, add chart element, axes titles, and you'll have to add a primary and a vertical. Sorry, primary horizontal and primary vertical. So it's a little bit different. And then
I have a question.
Yeah.
So which data set did you use for this graph? Because I made it and I have the curve and it's exactly the opposite way. It's like reflected. Like it goes from down to up.
I'm using the first set, so that just the time and the absorption. You might have used 1 over absorption.
Oh, so we're using the given experiment 1 data set?
Yep. So we're going to make a graph for each one of these to see if we're 0th order, 1st order, or 2nd order.
Thank you.
Yeah, of course. Okay, so this axis title on our left is absorption. or absorbance, whichever one,
Yes. I got
absorbance. If you want to add units, these are arbitrary units, so you just a dot u dot or arbitrary units. And then our x-axis is going to be time in seconds. You don't necessarily have to do this. These data points are taking up approximately 80% of the graph, but I am just going to anyways. I'm going to extend out. So I'm going to go to format axis and I'm going to make my maximum 600. And then you need to add a trend line. So you'll press up at the top, the chart elements, or you can go into chart design, add chart elements, add a trend line. And then this makes it look really funky. So I'm going to do some additional things. One, you're going to want to format your trend line. So you're going to click on the trend line itself. You can always tell if you've highlighted something because there'll be dots around it. And then you're going to right click, or if you're on a Mac, you'll do the 2-finger double click thing. And you're going to go to format trend line and you want to display equation on chart and display R squared value on chart. And then lastly, I don't like, if my data doesn't go below 0, I don't like to start below 0. So I'm going to change this axis, go to format axis, and I'm going to put my minimum value as 0. And that'll pull it all back in. And then it should look something like this.
I have another question.
Yeah.
So when I typed in my axis titles,
Mhm.
they're overlapping with the measurements.
Okay.
Like the words are on top of each other.
Okay. You can click on this and sorry. You can click on this and you can drag. You should be able to drag. Wait, sorry. Click on this and you can make your data smaller if you need to, and then you can move that. So just about everything in here can move.
Thank you.
Another thing you do is you could just make your graph bigger. That will also usually fix it as well.
Wait, I also have a question.
Yeah.
How did you get it to just be 600?
So you can click on whatever axis you want to change the scale or the range, excuse me. You're going to click on it. Again, you see the little dots around it, so we know we've highlighted it. Right click or 2-finger click, go to format axis, and then it should bring you up to a minimum and a maximum.
Where does it say format axis? When
So
I click on it?
You have to
Oh,
double click or right click, and it's going to be down at the bottom.
And I'm starting with this.
But you have to make sure you're highlighted on whatever it is you're trying to change.
I don't think it is letting me, but
Let me share your screen for a second.
never mind.
Oh, did you get it?
and it says so once you clicked on it, what did you click afterwards? You clicked on
So yeah, click on it.
size
Then
and properties.
no, format axis.
Maybe it doesn't show. Oh, format axis found it. There we go. Okay. And then minimum to 600.
Maximum to 600.
Oh yeah, maximum. Thank you. And then how did you get the y equals and the R2 value again?
You're gonna click on the trend line itself.
Okay.
And then you're gonna click it again, format trend line. So anything you want to change, you're gonna right click or double click to go to the format option. And then on the right, we see display equation on chart and display R squared value on chart.
Perfect. Thank you.
Okay. We also have one more thing we need to change here. We need this to be in scientific notation, the trend line label itself, scientific notation with 4 decimals. So again, we're going to highlight it. We're going to see the little dots around it. We're going to right click or double click and go to format trend line label. So format trend line label, there's several different options here. Make sure you hit the format trend line label. And then under category, change this to scientific. And decimal places, change this to 4. And press enter. And then we'll have a trend line label in scientific notation with 4 decimal places.
Alright. So with this, we have our moles of oxygen to cancel. And then we have that.
And then that is a proper graph. So that has all of the things that we need in our graph. We have descriptive titles. We have a zoomed in graph to make sure that our graph points are taking up most of the graph area. We have a trend line label or trend line equation and R squared value in scientific notation with 4 decimal places. So we're going to do that for every single one of our graphs. So I'm just going to take this graph and
So essentially then.
go over here real quick. And I'm
I
going to
have a question on grading.
about grading.
So my graph, when
Uh-huh.
I tried to get the words to not overlap, now my graph is really, really rectangular in shape compared to yours. And I was wondering if that would be acceptable.
Like that?
Like yeah, like that.
That's fine.
Thank you.
Yeah, the shape doesn't matter. As long as you got the important information.
Could you show one more time how you got like the function? You know how you took the original graph and then made the ln of it? Could you show one more time how to get the like first data point? I know you click on like the bottom to make it all of that, but
So yeah, so you're gonna type in the wherever you want to do the equation at, you're gonna type equals, and then we're doing the actual function ln. Oops, that's 2 L's. ln. Open parentheses. Then you're gonna click on the absorption value, close parentheses, and enter. Excellent. Okay, so we've got our first graph done. Sorry, go ahead.
Also, my numbers like on the bottom where it's seconds is like overlapping on the graph instead of actually like being like down below. And I don't really know how to fix that.
So click on the graph itself and kind of squish that, and then you can kind of.
Oh, okay.
Yeah, so if you click on the whole graph, you can actually change the size of this graph, which I wouldn't actually change it to that size, but you can change that, or you can make it much bigger. Right. So you just adjust, and then you can move these as well.
How did you remove the like my graph goes to on the y-axis minus 0.2? How did you change that? I knew how to change the x-axis, but not the y-axis.
Oh,
bound.
okay. So you just do the same thing. You're going to click on the axis itself with the numbers, right click or double click, then go to format axis. Mhm. I did one. Oh, sorry.
Did this one?
Could you please walk me through that? Because I tried to change it and now my whole graph is gray because I added a bunch of extra lines, I think. I'm not certain.
I'm sorry. I was away for just a moment. What'd you say?
Could you please walk me through how to change the x-axis because I tried to do it? I mean, the y-axis because I tried to do it. And now I have so many lines on my graph, it's completely gray.
Okay.
Like
press undo first.
Yes, I've gone in and undone it.
Okay, so you're gonna click. So make sure this whole thing is highlighted. Then you're gonna right click or again double click, and if it undoes it, okay. And then format axis. Right here. That'll bring this up, and all you need to do is change your minimum to 0.
Thank you. It works now.
Excellent. Okay, so this graph is done. So I'm going to put it to the side, and I'm going to do the same thing to the other 2 graphs. So I'm going to say what I'm doing out loud, but I'm going to go kind of quickly through these next 2 graphs. However, I'll leave the graphs up so you can see what they should look like, and hopefully get your graph to look the same way. Okay, so I'm gonna select my next two sets of, or my next two columns, insert my scatter plot. Ooh, hopefully we notice that this is linear. And we notice that that one was not linear. That should give us some information. Okay. So I'm gonna add in my titles. I'm gonna add in my trend line. I'm going to take my trend line, format, go to format trend line. And I'm going to display my equation and R squared value. Then I'm going to take my trend line label, format trend line label, scientific, 4 decimal places. Okay, real quick, another thing that I cannot stand is when my x-axis crosses above the bottom. I want it to be at the bottom. So we can fix this. So we're going to click on our y-axis. We're going to right click or double click and go to format axis.
So I know I'm starting out with 6.6.
And over here, we're going to have our minimum maximum like we expect. And what we're going to do is where it says horizontal axis crosses. So that's saying where on our y-axis our horizontal axis crosses. We're going to change this from being automatic to an axis value. And we're going to change it to what our minimum value is down here, -3. And that will put our axis down at the bottom. And then again, we can go through and change this one as well. Make that maximum 600 instead of 700. That one's not super particular. I just like to personally do that.
Could you please explain how you flip the axis again? I think I did it incorrectly.
Okay. So go onto your axis, your y-axis itself. Right click and double click, or double click to go to format axis, and then the horizontal axis crosses. You're going to change that to axis value instead of automatic, and put it as -3, which is our lowest number that we have on our y-axis.
Thank you.
The bottom part of my graph doesn't have like any numbers for some reason, and it, like the line kind of ends like in the middle. It's kind of weird. It's like my graph is too big.
You can make it smaller if you need to.
He drove that over trees.
I mean, you can
why-
share your screen for me to see what you're talking about. I can stop sharing for a second.
Mine's a little bit different because I'm doing it on like my computer. I have 2 different things. I could like show you. It's like I don't know why.
Are you on like your phone?
I'm on my iPad, yeah.
Okay, you could just.
Yeah, let's see here. I gotta figure out how to put my thing back up. I think. Does that show me? Can you see my face?
I can see your face.
Okay. Okay, then I'll try to like show you. I haven't labeled anything yet, but tell me if you can see my graph.
I can mostly see your graph.
That,
I can see
don't
the
like-
chemistry students.
I think it's gonna be somewhere over here because I think that's where it is.
Hi, Dr. Foley, are you in your office?
Yeah, honestly, I'm in the chemistry room.
If you want to just bring it down to me real quick, that might be
Yeah.
easier because I'm having trouble seeing
Yeah.
it. So just, I'm in my office. So I'll see you in a moment. Okay, for everybody else, as she comes over here, let's go ahead. Did everybody get to this point? The other thing we need to do is change our axes titles. Okay, someone's here. Who is here? Oh, Drew. One second. Okay. I wasn't expecting anybody here today.
It's okay.
Oh,
So,
okay.
Yeah, there's like no, but also on this one, I still cannot move that down to like have the numbers because they're like up here.
That's that one.
And I'm just gonna take this number
Okay.
here.
What is going on here?
Use it.
Yeah.
And again, once again. those are gonna come out. And then let the grand succeed.
It's like the numbers have completely gone.
Just 79.
Okay, let's,
Resistance high, by the way.
there we go.
Oh, okay, are we good? Perfect, thank you.
No problem.
And do you want us to switch this to 600 as well?
You don't have to, but I prefer it. Some things are things I'm preferring, some things are things that you will actually lose points for. You won't lose a point for that. Okay. So, okay, so this is now the natural log of absorption. And this is our time in seconds still. And then, as I was saying earlier, it's essentially the same thing here, except for just looking at the natural log of absorption. So I'm gonna be super lazy and just change this to crystal violet natural log of absorption. Ta-da! And there's a title that will work. Okay. The next one is a little bit easier of a graph. We don't have to change where the axis crosses. So I'm just going to go through that one as well. And like I said, I'll show you, kind of leave the graphs up and give you guys a minute. Insert. We're going to insert the scatter plot. We see that this is not linear. We're going to add in trend line, axis titles, format a trend line, create an R² value, format trend line label, scientific, 4 decimal places, not 74. Oh my goodness, just 4. I'm curious if it actually do go to 74. And then I'm going to change this to 0, crossing at 0. And then this one only going to 600. Maybe. Hello. Okay. Ah, there. And then again, I'm kind of lazy, so I'm. This is 1 over. And then we've got 1 over absorption.
So just email me.
Versus time in seconds.
Or come see me. Yeah, you have a lot.
Okay. So that is all we're doing for experiment number 1, are these 3 graphs. So we've got concentration versus absorption versus time, now the natural log of absorption versus time, and 1 over absorption versus time. Can anybody tell me what the order is with respect to crystal violet? And you can type it in the chat if you don't want to speak. I'm fine with that as well.
It's first.
How do we know? So it's definitely first. How do we know that it's first order?
Because the plot for natural log means first order and it's linear.
Exactly. So this is our plot that we're looking at. Okay. So I'm going to go ahead and make another sheet that I'm going to
What was
remake.
the title of the last graph?
I named it the same thing, but 1 over absorption.
Oh, thank you. So we just like include what we did.
Yeah. Yeah, because these are all the same thing. We're looking at all the same data. We're just changing what our y-axis is.
Thank you.
Yeah. And like I said, these are what your graphs should look like at the end.
It wasn't
so
easy, but a lot of it was for you too.
Okay. And like I said, I'm going to make another thing, another tab. And for this next one, we are going to want, so if we look into CSC Pub, we'll see that our second part, which is right here, we are trying to make one graph that has experiments 1 through 5 in that graph. So this one's a little bit tricky to make. It can be kind of a pain in the butt. So I want to ensure that everybody's ready. Is anybody not ready to move on to experiment number 2?
I'm not ready yet. Give me 1 second.
Whenever you are, just either say out loud or type in chat.
Literally
there's not enough time in the day. There is not enough.
And I imagine you have to do so much for.
Yeah, no, like my day is laid out from all the time, and of course, today is.
Okay, I should be ready now.
So you
Okay.
shorten to
Is
12.
everybody else good?
Places.
Yeah.
Yeah.
Or is there anybody not good?
They say it's not, but.
Right.
Okay,
you know,
let's go.
but,
Just make sure.
Okay,
Because you-
so we're gonna go back to sheet number 1.
When you do the tour, like,
Experiment 1 and 2, you may not realize this, but they've already done the natural log of those, mostly because the time scales are different on the 4 experiments, 5 experiments, excuse me. So if we look under here, we see that our first natural log is negative 11205. That is the same number we see right there. So all we need is, and they're doing natural log because we know it's first order. So in order to find the K effective for each of our graphs, we need the first order graph or the natural log of absorption versus concentration to get that K effective. So we are going to take and get the natural log of experiment 3, 4, and 5. So here's 3, 4, and 5. So in this, so we're on sheet 1 right now. I'm going to copy and paste this into another tab, but it's easiest just to do the math here. So we're going to type equals ln natural log, open parentheses, and then we're going to click on the first absorption value for experiment number 3, close parentheses, and enter.
I will copy too, so that's great.
We will then, I'm not going to double click on this one because it'll give us like tons of data. Instead, I'm just going to drag this down until I get to 200 seconds.
Well, it's so important to have different types of things. Oh, we get like really.
Uh-huh.
I do that a lot.
Yeah, but you like the pumpkin spice stuff?
No, so I'm a big fan of Guatemalan coffee. So
Then we're going to do the same thing for experiment number 4. We're going to press equals, type in ln, open parentheses, and then go up to experiment number 4. Click on its first absorption value, close parentheses, and enter.
World's bigger than.
Then we're going to click on this little box and pull to 200 seconds.
No, that's how I got hooked on it. I went to Guatemala and they served coffee, which I've been.
Yes.
And then we're going to do this one more time for experiment number 5. So we're going to type equals ln, open parentheses, the absorption value for experiment number 5, close parentheses, and enter. Then pull and drag, or click and drag.
It was awesome. I wish I had.
Yeah. Yes.
Well, thank you so much. I'll be back again.
Sounds good.
Look at all the little chemistry majors. Oh, they're going off to class. Good students. Okay, so now we're going to take all of this data. So we're going to drag down to 600 seconds and make sure you get all 6 columns. So we're going to have our time column, our experiment 1, 2, 3, 4, and 5. We're going to copy these. I'm going to go over to experiment number 2 tab. And again, you don't have to necessarily do this. I just like this so that I have plenty of room for my graphs and I don't get lost of which graph is which. Okay, now this is what we're going to do. We're going to do go to paste up at the top, and we're going to go to paste values.
So to clarify, we're using the new data that we've just made on that second chart.
Uh-huh.
And we're just copying all of it from experiment 1 to experiment 5.
1 through 5 all the way down to 600 seconds. Yep.
Thank you.
But you want to make sure you paste values. If you just press paste, you'll get a bunch of references. So see how it all says REF? Instead, we want to make sure that we are pasting values. Oh, there we go. So
I have it copied and then I'm going to paste it somewhere else.
Yeah, I put it on another tab.
Should I do that or can I keep it on the same spreadsheet?
Up to you.
Thank you.
Like I said, the only reason I do it on another tab is so that we have, like I said, 5 graphs that we're doing here. So having on different tabs helps me to keep up with them. Like this is the parts that are going to go into experiment number 1. This is my experiment number 2. And then I'll have an experiment number 4. Or part 4, I guess I should say. So I just like to keep them separate so I don't have too many graphs on one sheet. I'm gonna check something real quick. Don't follow me yet. I'm just checking to see if this works. I don't think it will, but it might. Oh, it does. Okay, sweet. Check one more thing. Oh, okay, yeah. Excellent. Okay. So we are going to take from A2 all the way down. We're going to select all the data we just put in here, and we're going to insert a scatter plot. And we should get all of our data points on this one graph. I'm gonna make this way bigger so I can see it.
My scatter plot looks very, very different from yours,
In what way?
and I'm not sure why.
Can
My experiment 1 and experiment 2 data points are practically touching.
you share your screen so I can see what happened?
Yes.
I will stop sharing for just a moment.
Let me see how I can do that. I'm not sure how to share my screen.
It should be at the bottom. Are you using the app or are you using the online version?
I'm using the browser version.
Okay, that could be why. Do you have the app?
I do not right now. My computer's low on storage.
Okay. Are you on regular Excel or are you on the
I
online
am
version?
on the desktop Excel.
Okay,
I
that's
mean
good.
the not desktop. I mean like downloaded. That downloaded application. I just have the browser Zoom.
But it's not a browser version of Excel.
No.
Okay. So walk me through what you did. I'll share my screen again.
So I highlighted that entire section from.
You did not need to include these up here?
I did include those.
Don't get rid of those. Okay, so undo what you did. Just take the numbers themselves.
It still looks different from your chart.
Okay.
Mine only goes up to 250 on that x-axis instead of to 700.
On your first axis, do you have all the way down to 600? So for your time slot, does it go from 1 to 600?
So, oh, I don't think I pasted the values all the way down to 600.
Okay, so that's probably the issue.
Thank you so much. I apologize.
Yeah, of course. Okay, we'll give her a minute. We are going to change. So see how it says series down here? We're going to change these names. So we're going to click on our data points and we're going to go to select data right here. And it should give us our series. We're going to change these from series to experiment. So everywhere where it says series, we're going to change that to experiment. So all we do is press edit, and under series name, we're going to put experiment 1, or we could do exp1, whichever one you prefer. And we'll do that for each of these. now we have names of what these things actually are. Is this an actual legend? It is a legend. We do need a legend on here if you don't already have one. It should have put a legend in, but if you don't have one, make sure you include one so you know what each of these colors mean.
Is there any way you could show how to do that again?
How I added the names?
Yeah.
Yeah, absolutely. You're going to click on your chart. You're going to right click or double click and go to select data. After you get there, you're just going to go to each of your different areas and select edit, and then you can change your name under where it says series name. Just put whatever you want your name to be. I put, and it could be experiment, or it could just be, if you want it to be a little bit shorter, it could just be EXP or EXPT. Either one's fine.
I think I found my issue with the graph. The experiment 3, 4, and 5 data points, do they only go up to 200?
They do, correct.
Okay, thank you.
Yeah. So one of the things I was saying is make sure you're not going beyond this point. So if you go beyond this point, you'll get these weird number things. So if you got that, make sure you delete those.
Okay, so I had it right the first time. So, I would copy all the way down.
Yeah, so you need to go through all the way down to 600. And you're going to copy and then paste in here.
Thank you. It looks correct now.
Okay, great. Okay. Now, is everybody at the same point? I saw a thumbs up from Bree. Anybody else? Sorry, you're the only one whose video I can see right now. But I appreciate it. I got some more thumbs up. Excellent, excellent. Okay, so let's add some trend lines in. Now, you'll notice that we can add in a trend line, but it'll only add one trend line in. So all we need to do to continue adding trend lines is click on the next one and add it in. Next one, add it in. Next one, add it in. Next one, add it in. So you have to add it in for each one individually. Again, this is a personal preference. It's going to add into our legend our trend lines in there. I don't like that. So I will click on the entire box and then I will click again, and then you can just literally delete it. So you click, click, delete, click, click, delete, click, click, delete. And again, you don't have to do this. This is just personal preference because I don't need to see what the trend lines are. They don't need to be in the legend. But again, you don't have to. We will also need to go to each of these trend line. So this is the biggest pain. We have to go to each of these trend lines, format the trend line, equation, R squared value. And in addition to that, we will need to edit those, format trend line label, convert them into scientific notation with 4 decimal places, like so. So you're going to do that for all 5 of your lines. So click on the trend line, format the trend line, display equation, display R squared value, 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 and then convert them all into scientific notation with 4 decimal places. Scientific notation, 4 decimal places. Scientific notation, 4 decimal places. Scientific notation, 4 decimal places. And enter. Okay, and make sure that you kind of put the trend lines, the trend line labels where we can read them. If you need to for this one, you can extend your x-axis to give you more space on the right. So, like you can go through and you can change this to 800 if you prefer, so you have plenty of room for your trend line label. So it's clearly visible, and we can read it and everything like that. And you can, if you want to, you can increase the size.
Could you please show how to format it into scientific notation again?
Sure. So you're going
Thank
to
you.
click on the label. Right click or double click, go to Format Trendline Label, and then on the right, Scientific, you're going to Category, Scientific, Decimal Places 4.
Thank you so much.
Of course. I'm also going to, again, cross at the bottom. So I'm going to click on this one. I see that my minimum value here for my y-axis is -8. So I'm going to have my horizontal axis crossing at -8. And then I'll put that down at the bottom. Then it's just about adding chart titles. So this is experiments 1 through 5. Natural law of crystal violet absorption versus time. Reacting NaOH, something like that. And then this is natural log of absorption, and this is time in seconds. And then our trickiest graph is complete.
Is it okay if I come down there again and you help me? Because the bottom numbers have gone away again.
What you need to do to get that to work is you need to go over to add chart elements.
Where's that?
Add chart elements, and then make sure you have both of these selected.
So axis, so vertical.
I just found that really disturbing. But then, like,
Okay, and then how did you change the line on the bottom? Oh, no, I figured it out.
Nothing else.
So like,
Yes, I think of it.
Okay, excellent.
Could you show again how you flipped the x-axis down to the bottom?
Yep. So you click on the axis itself, double click or right click to go to Format Axis, and then you want horizontal axis crosses as axis value -8.
Thank you.
Okay.
My graph just completely disappeared when I double clicked it, and I don't know what that means.
Press undo.
Yeah.
How do I? Where's that?
Should be up
you should be squatting down like you're
here somewhere. Looks like an arrow.
This can't be good.
Aha!
Well, that baby breathing.
Okay. Is everybody good? Does everybody need a minute
I,
before we move on?
Set -8 for the axis value,
Uh-huh.
but it has not changed.
Did you press enter?
Let me see. So I would do it with the x-axis. I'm making sure I'm clicking on the right axis.
You're doing it with the y-axis.
I'm doing it with the y-axis? Okay. Thank you. It works now.
Okay. Does anybody need any more time before we move on to the next part?
I do. I'm just putting my titles in though.
What was the vertical axis on that one? And how would you write the units?
It's going to be the same units for the axes. So natural log of absorption versus time in seconds.
Thank you.
Okay, this next part, I'm going to talk about how you're going to do it. But I'm going to let you guys do the math on your own, and y'all will do it later. Because today we're really just talking about the graph, but I do want you guys to know how to do the calculations. Okay, so in this next part, we're trying to figure out what the order is with respect to sodium hydroxide. So we see in experiments 1 and 2, we change our concentration of sodium hydroxide. However, we need to figure out what the concentration of sodium hydroxide is at the start of the reaction. So to do that, we have to keep in mind that we are adding 5 milliliters of sodium hydroxide and 5 milliliters of crystal violet and 1 milliliter of sodium hydroxide. So to find the sodium hydroxide, I'm using this to find our sodium hydroxide concentration for experiment 1. So you're going to do it for experiment 1 and experiment 2. You need to use M1V1 equals M2V2. So our M1 is our initial concentration. Our V1 is the volume of our sodium hydroxide we added. And our V2 is our total volume of solution once we add the two together. So you will do this for both experiments number 1 and experiment number 2. Okay. After you have completed that, we are then going to go through and solve. So as I was saying earlier, what we essentially did is we set K effective, which is our slope for each of our graphs, equal to our hydroxide concentration. Oh, sorry, more than just that. Our K value times by our hydroxide concentration. And then we don't know what the order of that is yet. And that's what we're trying to find out here. Some things to note, our K effective does change with our different experiments because we're either changing concentration or we're changing time. However, our K value for experiments 1 and 2 are going to stay constant because the temperature stays constant. So using experiments 1 and 2, which is what I was talking about here just a minute ago, we are going to be able to find out our order with respect to sodium hydroxide. So what we're going to do is we're going to take our K effective from experiment number 1, divide it by our K effective for experiment number 2. We're going to set that equal to K over K, and then times by our sodium hydroxide concentration for experiment number 1, divided by our hydroxide concentration for experiment number 2, and all of this will be to the n. As I said earlier, our K values are constant, so those will actually cancel out. And we'll just be left with K effective 1 divided by K effective 2 is equal to sodium hydroxide concentration 1 divided by sodium hydroxide concentration 2 to the value of n. And n is what we're solving for. As a note, you are not going to get a whole number here because this is actual experimental data. So you are going to round to the nearest whole number. I will tell you now, just to kind of save ourselves some time, that n is going to be what number you're going to round it to is going to be 1. But you need to show your math for that. So you should get a value. It's going to be something like 0.6 or 0.7 or 0.8 or something like that. You will need to use natural log, or you'll do log of each side, right? So that you can drop this n value down. But that's how you're going to approach that problem. Try that out. See if you can do the math. Come see me later if you have any trouble with it. It's really hard without seeing the math to actually help you with that. But I do have office hours tomorrow and Friday and every day next week as well. I actually have office hours every single day except for Monday. But I'll be around on Monday anyways. Excuse me. Okay, so that's what you guys are gonna do for experiment number 3 or part 3 or whatever. It's confusing that they keep calling them experiment. This is actually we'll just call this part 3. So for part 3, you're gonna find out what your n value is. But you do again need to show all of that math. So you'll be doing it by doing M1V1 equals M2V2 to get your hydroxide concentrations. You'll put those values into here and you'll solve for your n value. Okay, so that is everything for part 3. And our last part of this lab is going to be finding out what our we're going to be creating an Arrhenius graph to figure out what the activation energy for our reaction is. So we're going to go back to sheet number 1. And we're going to copy this right here. So the Arrhenius plot information. And I'm going to add. Going to add a tab. I'm going to start changing this to part. I'm just confusing myself with all the experiments. I should just call these parts. You don't have to change these. I'm just. Okay. And we're going to paste those values in right here. Oops. Oh, I have to recopy these. Sorry about that. Control C. Control V. Okay. So the first thing we need to do is we need to, so we see we're looking at experiments 1, 3, 4, and 5. We first want to change our temperature for those experiments into Kelvin. So we're going to, again, get Excel to do the math for us. So we're going to press equals, and then we're going to click on our temperature, or the cell that has temperature, and then we're going to add 273.2. So that will allow us to go from Celsius into Kelvin. And we're going to double click so we can apply that math to all of these temperatures. Okay. After that, we're going to take 1 over that temperature value. So we're going to type equals 1 / and then the temperature in Kelvin. And enter. And then again, apply that again. As you get numbers that look something like that.
I am not getting as many decimal places as you are on that last one.
Okay, you can click on, so if your cell is larger, it will give you more numbers. So it could just be because I zoomed in. It could just be
Okay,
this.
yeah. So is that okay?
It has the number that this actually is this number right here, right? Whether you see that many decimal places or that many decimal places or that many decimal places, it's still the same number. So it won't matter.
Thank you.
Okay, next.
Wait, what did you put in for the k to the -1 power again? You did equals to what was that?
1 divided by our temperature in Kelvin, or 1 / the cell with temperature in Kelvin.
Thank you.
Okay, next we're going to put our K effective values. And we're going to have to get those from our graph in part 2. Okay, I also want to point out, please see that experiment number 1 is blue. Experiment number 2 is orange. So do not get this one. Get this one. We are taking the slope, the positive slope. So we're taking our slope is negative, but remember that our slope is equal to negative K effective. So we just want to take the positive value And you can, if you want, just literally copy it and then paste it. Now, please note, and do this for all of these, I have a lot more. I have a lot of decimal places here, right? Oh. So I did not just put 4.3 e to the -3. I copied the actual value from this graph, which is putting all of the decimal places in. Please also go ahead.
How precisely did you rather than just copy and pasting it?
I have no idea what you said. It was very staticky.
How did you get the entire number instead of just copying and pasting?
So I did. So what I did is I went and I highlighted the number without the negative, without the X. And then I just Control C and Control V.
Thank you. So that would give you the entire number?
Yep. And if you're only showing 3 decimal places, all you need to do, and it doesn't matter, but all you need to do is go to Format Cell, go to Scientific, and 4 decimal places.
My 4.131 is negative
Get rid of
on
the
my
negative.
graph.
Erase it.
Do I include that?
Do not include the negative, do not include the X. So it should just be the positive value.
Thank you. But it can stay negative with the X.
The exponent should be negative, yes, but the actual number should be positive.
Thank you.
Yep. Okay, so those should be our different values. And those are what we're going to make our graph out of. So we're going to make our graph out of, oh, sorry, I lied. We need to take the natural log of our K effective. So natural log of K effective. And that will allow us to produce our Arrhenius plot. So Arrhenius plot is 1 over temperature in Kelvin versus the natural log of our K value. So we're going to do another math thing. So we're going to do equals ln open parentheses, the number we just got, close parentheses, and enter.
Going, how
It's still not letting me
that would be
copy
our
it.
solution, but they'd be
Do what?
really close together.
Like every time I highlight it, even like without the negative and without the X, and I hit Control C, it's not copying it.
Are you on a Mac or a PC?
And someone was like, so how's
So
that?
it should be Command C.
Hopefully that works. Let's see.
Like literally.
I have a question about experiment 5. My slope on that one, I don't have a single number that looks like the one that you have. Yeah, my number does not look like yours. I have
It's
like
not.
-8.
That's experiment number 4.
Okay, and then like I just don't have one that looks like 1.04.
Did you forget to, do you have 5 lines on your graph?
Yes.
You're gonna have to show me later because without being able to see your graph, I have no idea.
Okay, thank you.
Yeah. It's our TA. Everybody say hi, Rosa.
Sorry, yeah, like, it's just not working. So like, isn't like copying.
Where are you putting this at?
Oh, experiment 3.
So, where is this? Yes. And then Command C. Mhm.
And am I gonna do that for each one?
Mhm.
Thank you. And you said Command B?
It's to paste, yeah.
Okay.
So you have, after copying, you have to paste it. Just keep zooming in on all the students that come in. Okay. Is everybody good? We're about to make the graph for this last part, so I want to make sure everybody's good. Everybody have the numbers they need. Okay. So to make our graph, we are going to highlight our 1/t, and then we're going to press Control or Command, depending on if you are in a PC or a Mac, and then we're going to highlight the natural log column as well. Again, make sure you're just getting the numbers. Don't take any of the other stuff. After you have both of these columns highlighted, you're going to go to Insert and Scatter Plot. And it's going to look something like this, which is not great. We have lots of things we need to do this graph before it looks good. But it should look something like this.
What was the formula that you used on the INCEF section?
It's ln k effective. So equals ln, open parentheses, click on the k effective, close parentheses, enter.
Thank you.
Wait, how did you highlight the separate columns? I'm so sorry.
That's okay. So click on the one. Click on what? Sorry. Click on one set of data, then you're on a Mac, so press Command. So hold Command down, and then click on the other column.
No, she can't.
Oh, I didn't see that you did the initial. What was the equation you used for that? I'm so sorry.
Oh, equals ln, open parentheses, click on the cell that has the thing in there, and then close parentheses and enter.
Oh, so KEF. And then enter.
So do you use those two data points in the scatter plot that you have here?
Yep.
My scatter plot has a really, really large amount for the x-axis, from 290 to 325.
That's because you use temperature instead of 1/temperature.
Oh, so all right, thank you. So I'd use the okay.
Whatever temperature.
Thank you so much.
Mhm.
Yeah, I see.
Okay. Does everybody have a graph? Okay, so let's start doing the things we're supposed to do. We want to add a trend line. We want to add axes titles. We want our trend line to have an equation and an r-squared value. So we're going to format our trend line, equation, r-squared value. We do need this in scientific notation. So format trend line label, scientific, 4 decimal places, enter. And now we really need to zoom in. So I'm going to click this axis. I'm going to put this minimum as -4.4. And enter. Oh, oops, not minimum, max. Wait. Maximum. Wait, did I mess it up? Okay, I did that. Sorry. -4.4 is our maximum. -5.6 is our minimum. Sorry about that. There we go. Okay, that's what we want. So minimum -5.6, maximum -5.5. Or -4.4. Oh my goodness, those numbers right there. -5.6.
Did you do that with the y-axis?
The y-axis, yeah. Yes.
I did that, and now it goes from negative 5.6 to negative 11.6.
You want your minimum to be negative 5.6 and your maximum to be negative 4.4.
And it's negative 4.4.
Uh-huh.
Okay, thank you.
Okay. And we also want to put this axis crossing down here. So we're going to go to horizontal axis crosses, axis value at negative 5.6.
Could you please go through that slower again?
Sure. Which part?
Switching the axis down to the bottom.
Okay. You're going to click on your axis, right click or double click, go to format axis, horizontal axis crosses. So where it says that, you're going to click on the axis value and you're going to use the minimum value that we want it to be at, which is at negative 5.6 right there. So whatever your minimum value is on your bounds, that's what you set your axis value to.
Thank you. I apologize for asking so many questions.
My question is, my horizontal bottom part is now on the top.
Yes, oh my God, when are we
I don't know how to get it back.
When are we doing it?
You say about this is on the top?
Yeah, that's the top.
That's what I was just talking about. So you click on
Oh.
this,
Oh.
right click or double click, go to format axis, and you want your horizontal axis crosses at negative 5.6.
He does.
So the horizontal, the axis value at negative 5.6. Oh, okay, thank you.
Okay. This is an Arrhenius plot, so we can actually name that as Arrhenius plot. I will not take off for spelling because I don't even know if I spelled that right. And then this is going to be on our x-axis. We've got our natural log of our k effective, so ln k effective. And then on our x-axis, we have 1 over temperature. And that's going to be in Kelvin. You can be more specific if you'd like. This is a Arrhenius plot of k effective values for crystal violet if you so prefer, but Arrhenius plot is probably fine. This right here, this slope, the negative 3.4529 times 10 to the 3 is so if we remember what our Arrhenius plot is, it's ln k effective. In this particular case, k effective, or just k, is negative e a over r 1 over t plus ln a. So this right here is our slope. So we can set our slope equal to negative EA over R, and we can solve for our activation energy. So R itself R is 8.314 joules over moles times by Kelvin. So if we take our slope, multiply it by this, and we do need to take into account that our slope is negative, so we need to get rid of that negative. That will give us our activation energy. And then if we take our y-intercept in our graph, this value right here, the 6.6, or sorry, 6.1644. That's e to 0, so that just means 6.1644. If we set that equal to the, so the ln of a is equal to 6.1644. If we take both sides to the e, a will equal that e to the 6.1644. And we can find our a value. And that's the last of the math you guys need to do for this lab. And that's the last of everything for that lab, or for this lab. So for the most part, most people should be done with their graphs. If you are having trouble with any of the graphs, come see me. And we can see what's going on with it. I guess I should have told you guys to download Zoom, because you can't share your screen if you don't have the regular application version of Zoom. But you can also send it to me and I can look at it and tell you what's going wrong. Yeah, but does anyone have any questions before we call it quits for today? You guys are free to go. I will make this recording available. And if you guys have any questions, please reach out, and you guys have a great day. I'll see you not next week, but the week after.
So on the Arrhenius plot, the like slope, is that just like 3.45, times 10 to the third? Okay, cool.
Yep, so we say, okay, negative EA over 8.314 joules. Sorry. That's going to be equal to the 3 point, I've already forgot what the number was. 3 point.
It's 4529.
Sorry, negative 3.4529 times 10 to the 3.
All right, thank you.
And then if we multiply, that'll give us in joules per mole, because this is over Kelvin, right?
Got it.
Okay. Any other questions? Anybody have any things they want to ask?
Yeah, what time slots did you give us to take that quiz? I know you said within your normal office hours next week or something, or was it with our lab hours next week?
You can come in during any of my office hours this week or next week.
Okay.
Or you could just take it the next time we meet for lab. Just if you wanted to take it sooner, I'm fine with you guys coming by during a lab period. Or sorry, during anytime I'm in my office. If you're like, hey, I want to take this quiz. Because you may be more prepared for it right now than you will be in 2 weeks.
Yeah, understood. Thank you.
So yeah, just come by at any time.
All right, thank you. You have a good one.
Yeah, you too.